Let's subscribe.
Like, share, and leave the comments behind.
Welcome viewers. In this lesson we are going to analyze solid V. This analysis, we call it organic analysis. So this one is being done by a student, that's Adam. So you scoop, so procedure 1, scoop half spatula of solid V and burn it with a non-luminous Bunsen burner flame. So he's now scooping solid V using a spatula, a half full. Then now we will burn using a non-luminous flame. Good, that's why. So you see the observation, students? So solid V burns and melts with a yellow sooty flame. Good. So observation, solid V burns and melts with a yellow sooty flame. The inference, remember students, that any organic compound that burns with a yellow sooty flame, then it means it is either a double or a triple covalent bond. So you are supposed to illustrate a double bond as well as a triple bond. Now the next procedure, you dissolve the remaining solid V in about 10 cubic centimeter of distilled water in a boiling tube and divide it into 3 portions. It's now measuring about 10 cubic centimeter of distilled water. So to the remaining solid now you add a boiling tube in the distilled water. Shake the mix now. So the observation is solid V dissolves in water to form a colorless solution. Now any organic compound that dissolves in water forming a colorless solution, then note that that organic compound is a polar organic compound. Now divide that solution into 3 portions. Now, to the first portion add 2 drops of acidified potassium manganate 7. That is potassium manganate 7 acidified. Now add 2 drops to the first portion. See now the observation. So you can see that the purple color of acidified potassium manganate 7 turns colorless. The purple color of acidified potassium manganate 7 turns colorless. Good. So the inference that you are supposed to write is you illustrate a double bond, triple bond, or ROH. ROH is alkanol, so R-OH. So these 3 is being tested by acidified potassium manganate 7. Now to the second portion, you add all sodium hydrogen carbonate provided. So that is sodium hydrogen carbonate. So all of it you will add to the second portion. So observation. So you can see that observation, effervescence occurs. Effervescence occurs. So effervescence of a colorless gas occurs. So the observation is effervescence of a colorless gas occurs. So the inference is you are supposed to illustrate alkanoic acids, that is R-COOH, stroke hydrogen ions, stroke hydronium ions. Good. Now to the last portion, which is the third portion. Now you add, you determine the pH. Remember, for you to determine the pH, you use a universal indicator. So you dip the universal indicator being given. That's now the universal indicator, pepper. That's now the color change. Now for you to determine the pH, then the resulting solution that you have obtained, you compare with the pH chart. So viewers, which pH chart does the resulting solution corresponds to? So you can see it's a light red that you have there, so it almost corresponds to pH 4. So the observation that we make now is pH 4.0. pH 4.0. The inference becomes weakly acidic. Weakly acidic. Remember, students, remember, learners, that pH 4 is weak acid. Therefore, the inference, we have to frame it in a way that we make it weakly acidic. It is wrong to write weak acid. It is wrong to write weakly acid. The correct one is weakly acidic. Very good. That is the end of our analysis for today. Until we meet again, wish you all the best. Thank you.